Hello everyone. In this video I'm going to go over the absolute value equations and inequalities with some examples. So how do we define absolute value? Whenever we say absolute value of a number or any quantity, we mean the distance from that number x to the origin, to the zero. Like for example, when we say absolute value of -3, just mean we use just two like vertical bars. We just mean the distance from -3 to the origin, which is 3. Or when we say one absolute value of 5, we mean simply the distance from 5 to the origin, which is going to be 5. So it's kind of the outcome of the absolute value is always positive. At least it's 0. Because absolute value of 0 is simply 0. Distance from 0 to itself, the origin is 0. So when we have an equation like this, absolute value of x equals 5, you try to figure out the numbers whose distance to the origin is 5. Like on the number line, this is origin. You look for the numbers whose distance to the origin is 5. So we have two such numbers. One is 5 itself. Distance from 0 to 5 is 5, and then the other number is simply -5. So the distance from -5 to 0 is 5. So for this problem, the solutions will be x equals 5 or x equals -5. So we can just say the solution set is -5 and 5 for this problem. See, you can get two of those. If this is non-zero, if this is 0, then you get only one solution. So from this perspective, we can just say whenever you take absolute value of an expression equal to a number k, and k needs to be positive, by the way. Like for example, let me just write down an example. Look at this example. Absolute value of x equals -4, for example. This one has no solution, because this absolute value of x here, this quantity needs to be greater than or equal 0. It can't be negative. Okay, so just be careful here. Whenever you have an absolute value equal to some number, that needs to be positive. So that means whenever you have an absolute value equals to a number k, which is greater than or equal 0, then the expression inside the absolute value needs to be that same number or the negative of it. So like in this example, we have absolute value of x equals 5. We get x equals 5 or -5. Now let's take a look at this example. And you also have here a try yourself problem. So you can pause. After I solve this problem, you can pause the video and solve this problem. Now see here, 4x plus 3 is set equal to 27. So that means 4x plus 3 should be 27, or 4x plus 3 equals to -27. So we have two values because that's equal to 27. So whatever in the absolute value needs to be negative of that number or the number itself. So we saw that one. Subtract 3 from both sides for both equations. See, these will cancel. So in the first equation we got 4x equals 24, or 4x equals -30. Then the final step, we divide both sides by 4 so that we get x. Divide both sides by 4. See, from here we will get -15 over 2 if we simplify. So we got two solutions from here. That's x equals 6 or x equals -15 over 2. So those are the solutions for this problem. So negative 15 over 2 and 6. So I hope this example is clear. So now I want you to pause the video and work on this problem number 2. And after number 2 here, I put the solution here again in the same way. You get like 2 solutions. Set the equations equal to 1 or negative 1. Now whenever the absolute value is equal to 0, what do you do in this case? Can you pause the video and work on this problem, number 3? Problem number 3. In number 3, that's equal to 0, and negative 0 is simply 0, so you only come up with one equation, guys, to solve. Set it equal to 0 and you will get only one solution in this case for this problem. Now let's move to the next one. Next one is again a try yourself problem, but just be careful in this case. Can you pause the video and check this one for a minute? So probably you realize this one. The right side is negative 7. An absolute value can't be negative. The outcome of an absolute value, let's say in that way, it can't be negative. So that means this one has no solution. You can directly stop. So the right side needs to be at least 0 whenever you solve an absolute value problem. And we have another problem right here that you can pause the video and try. So now, as you see in this case, what you really need to do is isolate the absolute value. You move that negative 2 to the right side as positive 4. I mean, the right side becomes positive 4. So that simply gets the, we simply get the equation absolute value of 3 minus 3x equals 4. Then we solve in the typical way. Set it equal to 4 or negative 4 and solve it. So that's the way. Now, one other thing is when you have an absolute value expression is set equal to another absolute value expression, guys, in this case, you really follow this rule. If absolute value of A is equal to absolute value of B, now you have two options. A needs to be same as B, or A needs to be same as negative B. Now you may just say, hey, we may have negative A equals to B, but that's same as this equation. Or you may say negative A equals to negative B, but that's same as the first equation. You know, like those two are the same. Like I can just say negative A equals to negative B, simply can be represented by this form once you multiply both sides by negative. Or if you multiply both sides by negative, you can just say negative A equals to B. So actually you don't have 4 different equations. You have 2 different equations that you just simply come up with. So in this case, let's solve a problem. Like for example, this problem. We just said absolute value of 2x minus 5 equals 7 minus x. So we use the same argument. We have 2x minus 5 equals to 7 minus x, or we have 2x minus 5 equals to negative 7 minus x. Now I move that x to the left side, so I add x to both sides so that these two will cancel. Then I can, as you see, I can add 5 to both sides to move this 5 to the right side. So we have 3x equals to 12, so x equals 4. This is one solution. From here you need to distribute that negative first. So we have 2x minus 5 equals to negative 7 plus x. Now you can solve the equation. That's a linear equation. I subtract x from both sides, and then these two will cancel, right? And then I add 5 to both sides, so that the 5 on the left side cancels, and I got x equals negative 2. So that's the other solution. So the solution set for this problem will be, can write negative 2 comma 4. See, it's the same argument. You set equal to itself or you negate it. Now this, I hope this problem is clear. Now let's take a look at the try yourself problem now. You can try this one. Pause the video and try that one. You will see something interesting in this case. Yeah, now if you work on this problem, folks, really the thing is this, you set them equal to each other, or you set x minus 3 equal to the negative of 8 minus x. In one problem you get no solution. In one equation you get no solution, so you only get one solution. That may happen, just be careful, that may happen. So now we start with the absolute value inequalities. Folks, it's the same argument, but this time you have two options, either less than or greater than. Less than or equal to or greater than or equal to are really similar. So for example, if it says absolute value of x is less than or equal to 7, that means you're looking at all the numbers whose distance is less than 7. So simply you're looking at numbers between 7 and negative 7. So that means if an absolute value is less than k, a number k, that means it needs to be sits between negative k and k. So that really comes from this example. We can clearly see over this example. The next one, what if an absolute value is greater than a number k? Then in that case, we're looking at numbers, for example, let's take 5. We're looking at numbers whose distance is greater than 5 to the origin. So of course those are numbers that are after 5, like bigger than 5. But also you have the left side, which simply is represented by x is less than negative 5. So the numbers away from negative 5 towards negative infinity, and the numbers greater than 5 towards infinity, all those numbers satisfy this inequality, right? If you plug in negative 6, that will work. If you plug in negative 5.1, it will work. So we have two cases in this inequality. We have that expression greater than k, or the same expression less than negative of k. So that's why we have these two simple statements to solve those inequalities. And I'm going to show you that in the examples, and we'll see that better. Now look at, for example, this problem, this one. It says, let me just go down, and we have that problem as well. So let's take a look at this problem. Absolute value of 2x minus 7 is less than or equal 9. So 2x minus 7, that becomes like a compound inequality. Less than or equal 9, or greater than or equal negative 9. See, that absolute value needs to sit between negative 9 and 9 because its distance to the origin is less than or equal 9. That's like the argument that we have from the first type of inequality. See, like less than or equal 7 means it sits between negative 7 and 7. So now this expression needs to be between negative 9 and 9, and then we solve it. We solve it for x. So simply you try to isolate x. Sometimes they just write it in this way. I mean, which is fine. In some videos or textbooks you may just see that they just sometimes write it as 2x minus 7 less than or equal 9, or 2x minus 7 greater than or equal to negative 9, which is fine. You may solve it in that way, but this makes it more simple and faster for this type of inequality. So I add 7 to all three parts, right? So that this 7 will cancel, and I got -2 less than or equal 2x less than or equal 16. And finally, I divide all by 2 so that these two will cancel. So I have from here, I got x less than or equal 8, but also greater than or equal -1. So the solution set, as you see in this case, it's going to be the closed interval with a bracket -1 comma 8. So that's the solution set. So I hope this problem is clear. Now let's take a look at this problem, and of course we have a try problem next. So let me put some space. For this problem, see, it's greater than. Now you have to be careful, folks. It's gonna be again two-part equation, but you can't make it like a combined compounding inequality. So in this case, the inequality will have two parts. So one, just say 5x minus 7 is greater than 2. So the numbers needs to be greater than 2. Or you also need to consider the numbers that are less than -2 from here. And then you solve it in the same way. So I add 7 to both sides, that these will cancel. I do it in here as well. So you're simply following the same arguments. These two will cancel. I got here 5x is greater than 9, or 5x is less than 5. So then we divide both sides by 5. So these 5's will cancel, and here I divide both sides by 5. So see, all of these will cancel. So we got 1 on the on this inequality. So we got from here, we got x is greater than 9/5, or x is less than 1. See, we got two disjoint intervals. It's kind of like that. You have the number line. Here I have 1. Here I have 9/5, because 9/5 is bigger. Here's 1. Here's infinity. Here's -infinity. I need to take the numbers that are less than 1 and also greater than 9/5. See, that makes the solution set -infinity comma 1 with a parentheses union 9/5 comma infinity. Both parentheses because it's greater than. The equation part is not included. Equality is not included. So see, in this case, you follow the same argument, but you can't do it like in a combined way. You have to do it separately because they're disjoint intervals. So I hope this is clear. Now, can you pause the video and check this problem? Try this problem yourself. Okay, now, folks, this problem is it's really not that bad. You apply the same arguments. So for the same arguments that we have in number 3, it's a similar one. You set the expression between 5 and -5 and solve it, and then find that interval. Now maybe you can try. Now maybe you can try this problem. You can pause the video and try this problem, number 6. Now for this problem, as you see, it's greater than 20, so you have to make it less than -20 or greater than 20. Of course, like in this one, I just write it in the different order. It doesn't matter. You can write first this, next that one, second one, or you can write this one as first and that one as second. It doesn't matter. Order is not important. You're going to come up with the same disjoint intervals. And in here, you just solve it in the same way, and you get, again, two disjoint intervals. Now, some tricky ones, be careful. I put these examples in here. You can pause and check them. But if the right side is negative, don't forget an absolute value is greater than or equal 0. So if you have right side negative and that's less than or equal to, then the problem is no solution. because distance can't be less than a negative number. That's one thing. And then the final equation is if it's greater than a negative number, like that, absolute value is greater than or equal to a negative number, then this time the inequality is correct for any x. So the solution set will be all real numbers. You don't need to solve anything. So as you see in the absolute value equations and inequalities, if the right side is negative, then you have to be careful. You have to check it carefully. It may have no solution. In the inequality side, if it's negative, it may not have any solution, or it may have like all real numbers as the solutions. If it's the equation and if the right side is negative, then it has no solution. So I hope this video, this absolute value equations and inequalities are clear. Thanks for watching. Bye.